Hi everyone, my name's Jesse Cogdell. I'm the European Entertainment Specialist at Vectorworks. And today I would like to introduce you to a project that Vectorworks has been pioneering in conjunction with our partners at the GDTF group. So what we're trying to do is establish a new standard or set of standards for the entertainment industry for transferring data, both for inside lighting consoles and for CAD software. So let us begin. Now, the general device type format. Imagine a world where lighting fixtures just worked, first time, every time. This is what we're aiming at with the GDTF standard. It's founded on the premise that lighting manufacturers know precisely how their fixtures are designed to work and how they want them to be pre-visualized. Nowadays, we face many challenges to be able to deliver high-quality shows. Lighting devices and fixtures, they evolve at an ever-increasing speed. So we need to be able to accurately represent these fixtures in every piece of, or every part of the design process that we carry out. Not just in the CAD software like Vectorworks specializes in, but also for your lighting pre-visualization software and for your consoles. So what we're hoping to do is to simplify this process. And as you can see here, one of the primary challenges we face in our industry is that every single application, whether it's a console, a CAD, or a pre-visualization software, uses completely different standards for how they can represent and control these fixtures. For example, Vectorworks, we use parametric objects or symbols. A console personality file is required for a console, and a previs software uses another file format. And the fact that no single console brand uses the same format for the different console types. So, for example, an ETC Congo won't necessarily have the same fixture personality file as one of its older consoles, or the MA1 won't be compatible with the MA2 in this regard. It means that the lighting manufacturers and you, the users, can have huge problems to be able to actually get the data that you need to control the fixtures for your shows in a timely manner. So we are trying to simplify this process, as I said, and for the lighting designers who would like to use these devices, we're trying to find ways and means to make this process as simple and as easy as possible. We want the new general device type format to provide a new standard for the whole industry, a unified, standardized definition for any device that can be controlled by DMX. To start with, it's for lighting devices. But as we move forward, we're hoping that the standard can be extended to other devices, such as pyro video interfaces, loudspeakers. Basically anything or any device that we use in our show designs or need to be able to control, we would like the GDTF standard to be able to accomplish this manner for everybody in every application. GDTF will make the overall workflow that you need to design shows much more efficient. Fixture manufacturers need only provide a single file for every possible application. Ourselves as a lighting, ourselves as a CAD planner, lighting planner, or pre-visualization developer, we will receive the data in a timely manner. And for you, the user, this is important as well, because it means that you get the data provided in a standardized format that you can use anywhere. And this will also lay the foundations for further improvements and efficiencies in design. The GDTF group was founded by a partnership between MA Lighting, Vectorworks, and Robe. GDTF has been developed as an open standards technology. This means it is completely free for anybody that wants to implement or make use of the standard. We will help anybody who wants to implement it into their software. We want this to become a standard for the industry. This is not just for the partners. This is for anybody and for the users. As you can see here, the GDTF group has expanded. It now includes many of the major names in the industry. So as you can see, You've got Martin Lighting, you've got Clay Packy, you've got ADB, ETC. The more people we get involved, the more features and the more directions we can expand this file type into. And this list is by no means complete. This was just the last set of graphics that I've managed to obtain. Now, GDTF creates a file that's used as a unified standard. And to do this, it has to create all the data that every possible application needs. So it has to contain the 3D geometry of the lighting fixture. It has to include all the data for the lighting console. So the way we link this together is we link the DMX control data to specific parts of the geometry, as you can see here on the screen. So for example, the DMX modes are assigned to the base of a lighting fixture. If it's a moving light, the pan would be assigned to the yoke and the tilt to the head. We even model accurately the photometric data involved in all fixtures. This will give huge improvements for lighting pre-visualization in the future as well. So this is more of the data that we include inside of the fixture. So as you can see, we can even model or include the data for the type of LED emitter and the color measurements and photometrics, the DMX channel and attribute mapping for all modes, all the device geometry and physical attributes that are needed both for previs and for CAD, the mapping for how the channels are controlled inside the DMX modes, so you can use this to help generate things like your presets and your consoles, if your console is compatible with the settings. We also document the photometric data, and this is done as a standard photometric chart, and all the attribute matching functions. This is just a timeline of how we hope this is going to progress. So the initial project was announced in 2018. We've now got the first working standards, so it's now initiated for the MA3 console, and it fully functions inside of Vectorworks, and we're hoping some of the other console manufacturers will have working prototypes soon. I believe ChamSys has already announced its participation and has already got a fixture side working. And the next step in our project at the moment is we're going to be using it to model the behavior of media server control interfaces for lighting consoles. And as you can see, this is just a rough roadmap. We're hoping that every year or two we'll add a new range of functionality to the file format. And the format is designed so that in the future we can continue to expand on what we're doing. Now, the GDTF group has put a lot of effort into documentation and software tools to support this. We maintain an online wiki for anybody that would like to find out more information. This includes the complete specifications of the GDTF file type and how to set them up. We have an online GDTF builder which allows you, the user, to create your own GDTF files in addition to those created by the manufacturer. This can be useful, for example, if you want to create a lighting fixture for specialized rendering with high-quality textures. You can take the manufacturer's GDTF, adjust the geometry and the textures for the fixture, and save that as a linked GDTF on the website. We provide a manual and tutorial for the builder if anybody's interested in trying it out. And more importantly, we provide an online database of all available GDTF files. This is completely free for you, the user, to access. All you have to do is create an account, and then you can download the files for any fixture that are currently documented. And of course, we have the usual forums that anybody can get on board and ask questions and find out more. All of this can be found on the gdtfshare.com. Now, the second part of this, and this is perhaps the most interesting bit for Vectorworks ourselves, is that GDTF establishes the foundation for MVR. Imagine a world where data exchange between CAD software, pre-visualization software, and lighting consoles is just a click away. This is the possibility that MVR and GDTF provide. So MVR stands for My Virtual Rig. And this is a new bidirectional file type that we're hoping will become the standard file type for entertainment planning in the future. Again, this is an open standards technology. MVR builds on the foundation of GDTF. When you create an MVR file, it will include GDTF fixture profiles for all fixtures or devices currently available that can use a GDTF. The idea being that you can use this file to patch your lighting console, or you can export from your lighting console and set up your CAD software or your pre-visualization software without having to do it in CAD software to begin with. You just have to do your patch in the console. As you know, currently this can be a very tricky process. We have lots of challenges to overcome, but we're hoping this will lay the groundwork for a massive improvement in workflow in the entertainment industry. Now, the Mbr file documents everything that is not included in the GDTF. This means it includes all the design data from your design. Things like textures applied to surfaces, the position in 3D space of your lighting fixtures, the design geometry that's not related directly to the GDTF items themselves, such as your stage decks, your cloths, anything else that's required in your design. Data records that can be attached in the CAD software are also documented, and all the data for non-GDTF symbols. And perhaps most importantly for the lighting users amongst you, it will document the picked DMX mode and DMX address that you've assigned to your lighting fixtures for patch purposes. Now, you can see here that this is the kind of traditional workflow that we have when we're doing a lighting design or event planning. Getting your data from your CAD software into your pre-visualization software, we can mostly do that, but it's generally a one-way workflow. Getting patch data from your CAD software into your console, only a few programs can do that. And it's a single-way workflow. If you make any changes in the console patch, you have to go back and manually update your CAD file or your previous file in most cases. What MVR offers is a bi-directional communication link between all elements of the design process. So for example, you've done your CAD planning for a large project, you send it to the lighting designer. He's not happy with your DMX address or wants to move a few of your lighting fixtures. He can make that change in the CAD, either in the CAD software, like you would at the design phase, or you can do it directly in the console patch and update your MBR file and send it back to the CAD software to update your paperwork. You can also send the same file to the lighting pre-visualization application to update that at the same time. You can make changes in your pre-visualization setup and export the changes to both the console and the CAD software. We're hoping that this two-way communication link that we're trying to establish will revolutionize the way that you design and do your daily jobs in the entertainment industry. And the biggest thing that we're trying to do with this is to establish this for everyone. So this is a completely open standards technology, both for the GDTF and the MBR side. There is no costs involved, except your own development costs if you're a software developer. Okay, does anybody have any questions? No questions? Okay, well, thank you for paying attention. And if you do have questions or you have anything that you would like to know further about this, you can either contact myself directly, or you can go to the GDTF website and look at the FAQs or get on the forums. Okay, thank you for listening.
Thank you. Dziękuję Państwu. Ja już się z Państwem żegnam, a zapraszam teraz jeszcze na vlog prezentacji dotyczących dźwięku. Dziękuję bardzo za dzisiejszy dzień. Dziękuję. Do widzenia.